we have two components of velocity, right? Because waves are impinging obliquely to the flat surface of this continuity, we have one component normal to the surface and one component perpendicular to the surface. Which velocity has to be continuous? Or both velocity has to be continuous? Okay. One, both. Two, x direction. Third, y direction. Both direction. Raise your hand. One. Okay. Two. Okay. And x direction? Oh, 2, 4, 5. Okay. Y direction? 0. That means 7. That means 5 students gave up to vote, right? So why do you think the velocity has to be continuous in both directions?
I think
Mm-hmm.
equation vector equation.
Mm-hmm.
So we can go
Mm-hmm.
and we have many equations.
Okay, so you want to make as many boundary conditions so that we can solve the problem. So you just guess, oh, the more the better, huh? Right? Okay, well, that's very honest answer. What about you?
I think because the wave has two directions.
Two direction. So x direction velocity has to be continuous and the y direction velocity has to be continuous. In other words, we have fluid particle over here, medium 0 and medium 1. This fluid particle has to be continuously moved in this direction as well as this direction. Okay? Okay, the guy who said x direction only. Why? Uh-huh. Infinite? Because in y direction is infinity, so we don't have to worry about. Another? Dongsu? Which one did you vote? X. Gave up. You gave up. You gave up.
Now
You
both directions.
both direction. Okay, so we have one more. What about Seju? Both direction. It's increasing now. Let me ask you, the fluid we are considering is inviscid or what? Any assumption we made for fluid? I mean, this wave equation holds for any kind of fluid. In other words, the fluid we are considering can be distorted like this. You have a small conference over there. Okay. Yunje, do you think our fluid can be deformed like this way, shear deformation is allowed. Uh-huh. Uh-huh.
On the wall,
Mhm.
there is no solid condition, so there is velocity zero. So just the expression is considered on the wall.
Ah, very close, very close. Okay. I think what he said, this wave equation only for hold for inviscid. Inviscid. Right? Inviscid means the fluid that does not have viscosity. Right? If the fluid does not have viscosity, then the fluid in this direction cannot satisfy the no slip condition that he mentioned. It's allowed to slip. Right? Okay? Okay? Therefore, I can write, even though there are many boats over here, I can write the velocity in x direction on x equal to 0 has to be continuous. That is a physical description. How can you write that one mathematically? Okay, let me write the velocity vector, because we have oblique instance of incident wave and the velocity vector of reflected wave. In x direction, that I write Ex. Ex is the unit vector in x direction. Okay, has to be same as ut dot Ex. Okay, and the other one is the pressure has to be continuous, meaning that pressure in x direction has to be continuous. I don't care about the pressure in y direction. Right? So that I can write pressure in x direction, that is the pi as complex amplitude in the x direction is what? Pi exponential minus j omega t, and I have minus k xx, but on x this is 0, and ky I y, that is the pressure. Okay? And the other pressure is a PR. Ky r y has to be add up, and that has to be equal to pt exponential minus j omega t minus kt, ky t y, and note that this has to be k0. And this has to be k1. Okay?